This term significant figures, I'm sure, is a new term for most of you guys. What it means is it's essentially those figures or digits that carry meaning contributing to the precision of a measurement. So with looking at a number, you know how precise that measurement actually is. And a lot of times, significant figures is abbreviated as sig figs or even just SF. You'll hear other teachers sometimes call them significant digits or sig digs, but I usually use sig figs or SF. The first thing that I'm going to show you are the actual rules for figuring out significant figures, and the second thing I'm going to show you then is kind of a shortcut to get around those rules. Okay, let's start with the rules first. There are three main rules. The first rule is an easy one, and that's that all non-zero numbers are significant. The second rule is a little bit more complex, and it has to do with zeros. There's actually three different kinds of zeros in chemistry. The first zero that we're going to look at is called a leading zero. Leading zeros are never significant. An example of a number with leading zeros is 0.000036. All of the numbers that appear before the non-zero numbers are called leading zeros. These are not significant. So if we were looking at how many sig figs 0.000036 has, we would say that this has two significant figures in it. And those are those two non-zero numbers. The next type of zero is the captive zero. The captive zeros are zeros that are in between non-zero numbers. These are always significant. So for example, the number 0.003034, this has 4 sig figs in it. Again, these leading zeros are not significant. This zero that's in between two non-zero numbers is significant. So if we're doing our counting here, that's 1, 2, 3, 4 significant figures. The third and last type of zero that I want to look at is called a trailing zero. This is the most complex of the zeros. Trailing zeros are significant if there's a decimal in the number. Trailing zeros just are zeros that come after non-zero numbers. So if there's a decimal in the number that you can physically see, then those zeros are significant. So let me give you an example here. 0.0030345500. This number, first off, let's look at the different types of zeros we have in this number. These zeros are called leading zeros. They are not significant. This zero we just talked about is called a captive zero. It is significant. These zeros down here at the end, those are called trailing zeros. And because we can see a decimal in the number, those trailing zeros are significant. So if we were counting how many sig figs this number has, we would say 1, 2, 3, 4, 5, 6, 7 sig figs. The last rule that we have with sig figs are ones. Ones are for the most part not significant if it's all by itself. Okay, so if you see like 1 centimeter, we would say this has no significant figures in it. So ones, and we'll get to this, more examples of this later on, but ones, when they're by themselves, pretty much have no significance. So those are the 3 different rules with sig figs, and now what I'd like to show you is a trick to get around these rules. It's called the US trick. Let's take a look at a number that we looked at before, maybe 0.003434500. The way this US trick works is you're supposed to draw the United States around the number, and the reason for that is because on the left of the United States, hopefully you guys know that this is the Pacific Ocean. The P in Pacific is going to stand for present. In other words, there is a decimal present in the number. In other words, we can actually see a decimal in the number. And then obviously over on the other side here, we have the Atlantic Ocean. And the A in Atlantic stands for absent. Or in other words, we don't see any decimal in the number. So this number, we see a decimal right here, so that means the decimal is present. Anytime the decimal is present, we want to come over from the Pacific Ocean and keep on going until you hit a non-zero number. Our first non-zero number is 3, so that number and every number in the direction of this arrow right here is significant. So moving to the right then, 1, 2, 3, 4, 5, 6, 7 sig figs, just like what we got with using the rules. Again, the P for Pacific Ocean stands for present, or that fact that there is a decimal in the number, and the A stands for absent, or there is no decimal that we can see in a number. Let's look at a number where there is not a decimal that we can see. So let's look at 210,000 ribbons. That's the example I've given you. So here is our US. The decimal is absent, so we're going to come over from the Atlantic Ocean and we're going to draw an arrow and keep going till we hit a non-zero number. The 1 is the first non-zero number, so that number and everything in the direction of the arrow is significant. So that's 1, 2 sig figs. So 210,000 has 2 sig figs in it. There's one more example I've given you on your sheet, and that is 0.070700 grams. You can see that my drawings of the United States are pretty bad. So instead of drawing the United States, I'm just going to draw a box to represent the US. So we can see that decimal is present, so we're coming over from the Pacific Ocean, and we're going to stop at the first non-zero number, which is 7. That number and everything in the direction of this arrow right here is significant. So 1, 2, 3, 4, 5 sig figs. So that number has 5 significant figures in it. And that's how we actually count significant figures in a number. Counting of significant figures in scientific notation. And if you recall from before, scientific notation has a general formula, and that's A times 10 to the n. This A is a number between 1 and 10, and then n can be any positive or negative integer, including 0. These are the easiest numbers to figure out the significant figures for, because all you do is count the digits in A. However many digits A has, that's how many significant figures the number has. For example, 1.10 times 10 to the third if we look at this number 1.10, it has 1, 2, 3 digits, which means this number in scientific notation has 3 significant figures. Let's look at another one. 9.9 times 10 to the third. This has 2 digits in the number before the times 10 to the third, which means this has 2 significant figures. One thing I do need to mention here is that in order to count this way, we need to make sure that we are in proper scientific notation. So this number here must be between 1 and 10, which is key in order to figure out the significant figures. Let's try another one here. 6.022 times 10 to the 23rd is a number that you're going to see pretty often later on in chemistry. Hopefully you figured out that this has 4 significant figures in it.